It is my pleasure to introduce Dr. Amir Rahmani, who is a professor of nursing and computer science at University of California, Irvine, and a computer scientist by training. And he is the associate director of UC Irvine's Institute for Future Health, which is a university-wide quite amazing unit that I'm sure you're going to get to hear about today that focuses on personal health. And he leads the interdisciplinary health sci tech group. I'll try to say that correctly. And his work is really diverse, as you're going to hear about, and very, very innovative. Spans mobile health, data science, wearable and mobile computing, machine learning and AI, affective computing, biosignal processing, health informatics, and embedded computing, as you're going to hear about. So you're in for a treat, and please join me in welcoming Dr. Rahmani.
Yeah, thank you for the nice introduction. I'm so glad to be here and present some of the activities we do at our institute and also in my lab. As you can see from the title, the topic also intentionally is quite diverse because I just wanted to share the type of activities we do in the center, and also hopefully for a deeper dive, I would love to stay in touch with the team and see how we can collaborate down the road. That's why I'm including some of our activities, and I'll start with the notions of living labs and how we kind of incorporate wearable and mobile devices for data collection, or in other words, I call it sensing, and then how we kind of leverage technologies like AI and these days large language models for sense making part, as well as closing loop through interventions and actuations. So that's more or less about the very broad theme of this presentation. And of course, my focus is always on personalization and how we can leverage any information we collect, any data we collect, to better personalize, both modeling and actually interventions for the final end users. So I would love to start with this, what I call a notion of, living labs, because that's what we promote a lot in our center. And we, of course, are aware of all the benefits of having experiments in controlled settings, in labs. Of course, we can, control many confounders and really focus and zoom in on the intervention. But of course, there are also a lot of limitations, like we are all aware of the limitations of lack of like real world complexity, because oftentimes we need to oversimplify and isolate variables to ensure experimental precision, and that's why oftentimes also some of the findings lack generalizability, and we also usually don't have that much stakeholder involvement, because it's really in the lab, not in the communities, not in the actual real life settings. And also, due to all of those assumptions, we often have static interventions that we design prior to really the study being deployed, and we don't that much leave room for adaptivity and how to say improvement. So we promote this idea, of course, living labs. Of course, we are not the only group. I believe many other groups, including your center, also does a lot of research in everyday settings. And of course, the idea is having an alternative to traditional, lab controlled settings, and really enable designing and creation with stakeholders, not for them. So this user-centered co-creation is very critical. But to me, one of the most important aspects is the idea of having rapid iterations and flexibility. Really trying to kind of break that traditional cycle that usually, that oftentimes it lag behind, technological changes and societal changes, and try to kind of co-develop, test, learn, evaluate, and learn, and then go and improve, and actually continuously and iteratively kind of understand and improve and align the studies and interventions. So, of course, there are a lot of designs. I'm quite sure your group is also aware of designs that are aligned better with these kind of settings. For example, like smart sequential multiple assignment randomized trials is one good model where you can leave some room for adaptation to understand, for example, when first you randomize, let's say, to two groups or n different groups, then you can see who's responding. And if there are non-responders, then again, you can randomize them and assign more, different type of interventions to really kind of go away from that one-size-fits-all intervention to more at least a cluster of clustering participants into groups. But this is, of course, not pure personalization, but getting closer to that, towards that end. So this is one of course design which is mostly very highly aligned. But there are other designs like N of 1 where it's really like a personalized study design. But the issue is like one of the big issues, of course, we all know is really you want to go beyond your lab. You're gonna need a lot of data, not just on measurements. Let's say if it's certain physiology and so on. For example, you're looking at their elevation of heart rate or heart rate variability and things like that, but also a lot about their context, like what they do, where they go, their activities in the virtual world, in the physical world, because all of that is critical. And that's why I wanted to share this paper by my colleague, who is also the co-director of our institute, Professor Ramesh Jain. He's also regarded as the father of the field of multimedia computing. And we actually at our center really make the case that the lifeblood of research like this is really data. And we need to have a lot of data to better understand, as I said, understand the participants, the users, people through different lenses. And actually, when you look at how much data these days, especially in the healthcare system we're collecting, it's unbelievably, surprising. Just if you want to compare how much data you collect from your children, in healthcare system compared to your car, a modern car generates more data about its performance in 1 hour than we collect about our child's health in an entire year. Every aspect of a car has a sensor in it. There are more than 100 processors in each car, not even the high-end ones, simple ones. You all know about what happened when there was a chip shortage and the car manufacturing was hit the most. But why we only collect sometimes even kilobytes of data, or if not megabytes, which is like 1,000 times less than that. So really, we need to first of all understand that we need more data if you want to be more, better understand what's happening and be more effective. We need access to more data. So that problem, to some extent, has been kind of mitigated by the advent of course, devices. I just put some list. I'm quite sure you're also familiar with many of these devices, but these days, of course, we can collect the data from a lot of different low-cost wearable devices, portable devices. I'm listing some of them here, ranging from, for example, continuous blood pressure from Actia, it's a Switzerland company, all the way to Oura Rings and different devices. I know in your center, you're using also wearable devices for your research. And of course, for things like digital mental health, a lot of them are highly useful. I have done a lot of research, example, using heart rate, HRV, like respiration rate, electrodermal activity, and all of those to kind of capture objectively mental health outcomes, for example, using like autonomic nervous system activities and so on. But there are also even more devices getting closer to remote patient monitoring actually era. Things like Dream Headband for EEG or Sleep Profiler. It's very popular these days in the sleep community, this device. For example, for core temperature, looking at circadian rhythm and stuff like that, this device is highly being used. Or even less or more invisible devices like Sleep Pad by Wittings. A very low-cost device. I think it costs about $100 or $150, and through which you can get a lot of readings like sleep quality. You can get respiration, heart rate, even snoring, and those kind of activities. And it's almost invisible because there is no mobile phone involved. It's Wi-Fi enabled. There is no battery involved. It's already connected to the outlet, and you can actually, we are using this in one of our studies looking at dementia patients. and their agitation, and how their sleep and is affecting actually their next day mental health. And dementia patients don't want to wear a wearable device. That's why we needed to give them like something like this, where it's really kind of invisible, if you will. So the list goes on and on. I don't want to bore you with, of course, you can search and find a lot of similar devices. For example, this Backtrack Skin is another device that can help you monitor alcohol consumption and the level of alcohol in the blood. It analyzes your skin sweating, and actually it's a chemical sensor. And the list goes on and on. For people have used even devices like this necklace to understand eating kind of patterns, because every time you swallow, there are certain movements in your chest and so on, and also the volume of that. But the good news is that these devices give us a lot of data, right? But they, to some extent, they only solve one aspect of the problem, which is like, okay, we can now collect a lot of data, but there are still a lot of challenges. And one challenge, of course, is what if we have multiple devices and from different vendors, and also we have things like our ecological momentary assessments, our EMAs, our digital interventions. So running studies like, or building a living lab, which is actually a combination of a lot of technologies, still is a big challenge. I'll talk about that and how in our center we try to mitigate that, and we have built platforms for rapid prototyping of living labs. I'll share demos of that with you later. But one thing I also wanted to really kind of focus on is the fact that, of course, sensing is critical, but sensing is even more critical. Now we are talking about tons of data, right? And like that car example, they have solved that problem because they really kind of extract and mine actionable insight out of those sensory data. And that's why we also need more modern kind of ways of looking at big data, like things like event mining. In our center, we have built tools, open source tools. One of them is called Event Miner, which can actually help you transform your raw time series data into like more events. For example, rather than having a lot of just raw data on, for example, a certain, heart rate, or a certain like outcome like sleep, you can try to define rules and transform those to certain intervals and events. And then on top of that, you can look at, for example, co-occurrence of events or causality among events, and do cross-cutting type of analysis. For example, you have events on a certain activity, maybe you have events on physiology like heart rate, HRV, and you have also certain outcomes, and you can do cross-cutting causality analysis to see how these actual events are correlated or associated, and so on. And also, how, if you want to also on top of that provide digital interventions, in other words, closing the loop, that is also another usually very desired feature to have. But now I would like to start talking and going through some examples of some projects that I was involved, or at least our center was kind of supporting. One of them was this project we had by the National Science Foundation on smart and connected communities, recently ended. And the idea was how we can help pregnant mothers be more physically active and meet the ACOG recommendations of physical activity. And also we provided them with like a certain mindfulness and meditation kind of exercises to manage their stress. This grant, of course, was funded in the previous administration when still, we could serve the underserved. So, and this project actually was in collaboration with Moms Orange County, a nonprofit organization here in Orange County, primarily serving underserved populations. And what we did actually in this study, we gave these pregnant mothers a smart ring. We gave them a smart watch. At that time was Samsung. We tapped into the watch. We wrote our own program for the watch. to extract raw signals out of it and stream it to our server. So we totally bypassed like Samsung ecosystem. And that year, I think maybe we were the very first group who managed to do that and get raw signals, like really PPG, like 20 hertz signals, not even processed values like heart rate. And we could do our some of these data sets are, by the way, open. We also design our own mobile app to collect data about their daily, about some EMAs and weekly and daily data, as well as being able to provide our recommendations, exercise recommendation, digital intervention to them. So as I mentioned, the idea was we wanted to make sure these pregnant mothers actually meet this 150 minutes of moderate intensity aerobic activity every week. And unfortunately, many of them before the study didn't meet that recommendation. So our idea was, can we understand each person separately, build personal models, not giving them like generic recommendations, and try to help them kind of be more physically active. So this was a true closed loop implementation. We actually were in real time getting data from each pregnant mother. We were analyzing, like say, the baseline physical activity. Some of them were already highly active, and some of them not. So we wanted to really give personalized recommendations, not just something to everyone. That's why we use this notion of reinforcement learning and the reward modeling to every week adjust their level of physical activity. We even designed some exercises together with an exercise expert who was expert in pregnant mothers, and we trained the model AI, in fact, agent to do that. And the idea was that this is actually at that time the interface we designed. They would receive, for example, they would be categorized in different levels and would receive through the mobile app, the progress of their physical activity, how many times they still need to do that type of physical activity per week. We would capture how many minutes they have done it, and also the elevation of their heart rate, because not any steps would count as physical activity. We wanted to make sure they actually reach to that heart rate level to be counted as moderate intensity. And that heart rate was also supposed to be personalized because different people have different baseline. So you see, it was a lot of kind of engineering going behind the scene to make sure we capture and we give personalized recommendations. In fact, we even needed safety alerts because pregnant mothers' heart rate should not go above a certain number, and that's also personalized because it's calculated based on their baseline heart rate. I think more than 80% they should not exceed. I don't recall exactly the number, but that was a percentage above their baseline resting heart rate, if you will. Resting is a better word than baseline, yeah. So I'm just showing you some results of this study. I think the papers are out there. You can also, of course, I invite you to study those. But during, for example, this 12-week intervention, these are data for different participants, just some sample data. We managed to actually double the physical activity of these pregnant mothers. The minute is not that much because before that they were just like 15 minutes of physical activity per day, but we managed to make it like a double, close to half an hour. And it was not only the duration that was improved, but also the kind of the time that they spend in the light to moderate zone was also increased 64%. So meaning that those minutes were also more in the desired zone, not just slow walking and something that is not counted, at least by ACOG, as physical activity. So this is just one study. We also showed actually when we have a lot of data, we can do much more than that. This is actually another study on pregnant mothers. Half of them were high risk, half of them were not. About 58 pregnant mothers. We monitored them for, I would say, close to a year or maybe 9 to 10 months, because it was also postpartum that we monitored these pregnant mothers. And just their heart rate and heart rate variability generated like 3.6 gigabyte of data for this small population. We have, of course, sleep and physical activity and everything. But our question was, can we, because we were the first group who had that much data. In fact, every 50 millisecond, we had data from this, not even second, milliseconds. So imagine how much data we had. And unfortunately, 7 preterm birth cases we had in this population. So it was a good data, at least for a pilot exploratory analysis. So what we did, we actually built a deep learning autoencoder model. This is a very simple model to just understand what is normal and what is abnormal. So we built this model only based on the normal pregnancy, pregnant mothers. Normal, I mean like non-preterm births. And we try to see if this can help us detect the cases that were kind of the preterm cases or how different they are. And it was only based on HR and HRV, of course, a lot of HRV features, not time domain, frequency domain, and so on. And actually, the models were amazingly good. Not super like accurate because the data sample, the sample size was small, but close to 80% we could actually predict by only heart rate and heart rate variability the risk of preterm birth. And you can see the red lines here show the preterm kind of population and how much their abnormality score differs to the baseline. There's a clear gap. And if you look at also one by one some of these heart rate and HRV features, for example, heart rate itself, you see preterm birth group has much different patterns, and it can be even separated. Yeah, this paper is also, I think I can share the slide deck, but this paper is also published in Nature Scientific Reports, and I would encourage you to look at it. But I would like to, because I know that the center, your center, focuses a lot on youth. I wanted to also spend some time in another project we had on college students, primarily 18 to 22, closer to the population. I assume you guys are also interested. And perhaps this study maybe was one of the most complex systems that we needed to build to run a just-in-time intervention. I think I wasn't even sure at the beginning if we can do it or not, but to some extent we did it, but it was quite challenging at that time. So the idea was, I have a colleague, Professor Jessica Borelli, here at UCI. She is a clinical psychologist and also a professor of psychology here at UCI, and she has designed this nice intervention called relational savoring. And we wanted to see if we can provide this relational savoring intervention just in time based on data that we capture from wearable devices as well as smartphones, like locations, smartphone activities, like how many times they spend on social media, if they call someone or if they don't call, anything that we could get out of smartphones. Location, I don't mean exactly like coordinates, but more abstract information. For example, being in the dorm or not, staying in the home or going to gym or shopping or cinema and stuff like that. Really like trying to understand whether they're just spending all the time in the dorm or if they're going and outside and socializing. And that was actually the study. So if I want to summarize, we needed to collect a lot of data. All the data needed to go to our servers, to a machine learning model would receive tens of features from all of these. The machine learning model was supposed to make a prediction, objective prediction, whether they feel lonely at that moment or not. And if the prediction was positive, then trigger a digital intervention through their app. Everything in real time. This was really something I wasn't sure we could do it or not, because it was a true closed loop system involving a machine learning model that needed to run and do inference in real time. Yeah, so this is the study design. So we had this baseline period, about 6 weeks. In this baseline period, we only captured, or it was only observational, nothing. We gave all the devices, and we asked also self-reported EMAs about their loneliness. Why? Because we wanted to build the model. We needed first a personal model. It wasn't even personal, at least a model, a machine learning model, which can be used down the road for the actual just-in-time closed loop part, which started at this time. So first, we collected data. We quickly built the models, and then we deployed it in the field to two groups. One group did not receive the relational savoring. The other group, one group received it and the other group did not, so there was no intervention. And this relational savoring actually is an intervention, but in which like students, received mobile prompts to recall a positive memory with someone they cared about, and mindfully savor its sensory and emotional details, and sometimes writing a brief reflection to even deepen that sense of connection. So they could upload images about past, for example, connections with maybe their close ones, maybe parents, partner, and so on, and actually savor those moments. And then, of course, we had the follow-up also after the continued monitoring phase to see if they can, if the effect actually is sustained. We had a very diverse group, not a big sample size, but primarily like very highly diverse. And first, of course, I want to focus on the first part, whether we can even build a model that detects loneliness or not, because as clearly we see, there's a dependency between this part and the rest of the study. So as I mentioned, we gave all these devices to the patients, not patients, sorry, these were students, like, in fact, most of them healthy. And the idea, we actually collected all that data, and also every day sending multiple EMAs. In fact, I think 5 times a day, if I'm not mistaken. And we built machine learning models in a personal way. So for each participant, we personalized the model, because now we had some data, 1 month of data, not only from the entire group, but also from explicitly that participant. So for each of these 29 participants, we built separate models. So we personalized the models one by one. And just showing you, the average accuracy was about 82%, with AUC of 0.83. This is actually the paper that I refer to. But I want just to show you that it really different people have really different kind of how to say reactions to to loneliness. For example, here you see this participant A, a lot of his or her HRV kind of features were kind of highly predictive. Whereas this other person, when you look at these are shaft value explainable AI kind of techniques to look at and explain the predictions. Some of the activities of the ones that we collected from smartphone behavioral data was like most predictive. How much time, for example, this person watches Netflix on similar type of things and so on. So best sources overall, it varied person by person, but smartphone behavioral data, HRV, and sleep features were highly predictive. But as you see, it varied person to person, and we deployed actually personal models. This is it shows actually, it confirms the fact that different participants had different kind of features, which were more predictive for them, and you cannot just build a one size kind of fit all model for everyone, especially when it comes to mental health outcomes. The second part was, okay, now we have this model which at least performs 80 plus percent correct, not all the time, but sometimes is of course incorrect. Is the JITI, I mean the adaptive intervention, effective or not? So this is a separate paper. I think it's also cited in the cover page. Just published, I think, a month ago, the results. Here, actually, we qualitative results showed that participants found the intervention helpful and mood boosting. We ran into a lot of challenges because it was the very first time that we were running such a complicated, technologically at least complicated intervention. It was 2 years ago actually when we did this. We had too many prompts. Sometimes we had tech issues of this real-time loop was not fully working, so we had to debug a lot. Participants sometimes even had difficulties, generating new memories. So these are some of the findings. Also, the qualitative results, unfortunately, didn't show any difference. Both of the groups, slightly, their loneliness level decreased, but the intervention group was not more than the other groups, so more or less the same pattern. And we tried to dig in deeper, and we understood actually many of these are because of the fact that you really need better, perhaps HCI, better kind of involvement of the end users, allow them to even let you know when you want to trigger those things. Because, example, inconvenient timing was a big issue. Sometimes we alerted them, but that timing was really bad. So that also stresses the fact that you want context also to understand better when to send it. It might be that moment that you identify as a true loneliness moment, but not the best moment to intervene because that person is maybe already tied up with other things. So you want to maybe wait for a better time to intervene. So there are all these things that are highly important. Yeah, so that was actually the first part of my talk, more talking about the sensing and not getting that much into LLMs and kind of the conversational health agent parts. But I want to switch the context a little bit more now and talk about another technology that we have built in our center called OpenCHA or OpenCHA. And CHA stands for Conversational Health Agents or health CHAs. And we were actually among the very first group that published and started working on agentic AI in this field for healthcare. You see the paper was in 2023. At that time, agentic AI wasn't really that popular. And we are actually, and we were making the case and still actively making the case that LLMs alone are not sufficient. You need to build agents on top of them to make them more multimedia, more personalized, more empathetic, more knowledge and evidence-based, not just using only the training data, so retrieving data from validated sources and so on. And we believe the agentic architecture is actually the way to do it. So this is the OpenCHA, by the way, is open source. I'll show you a demo at the end and also show the website. It's called opencha.com. All the code, everything, and tutorials are there. I would encourage you to build your, and try it. So the idea was in this OpenCHA is, of course, everyone has an LLM that they use just for, interaction, like we call the result generator LLM. But here we have another LLM which does planning, meaning that it analyzes your prompts and reason and understand if for certain cases it needs to dig deeper and go, for example, and bring data from an external source. For example, it can be from your wearable or from your EHR or whatever. Or it need to go to an external knowledge base. For example, there is NIH has UMLS, or for nutrition, there's NutritionX. So there are a lot of curated, validated knowledge bases out there, knowledge graphs that can actually guide recommendations rather than just relying on data coming from internet in the wild world of internet. And also sometimes you have your own model. Maybe you have designed an LP model or a certain even deep learning model for a certain application, rather than just asking the LLM, sending a lot of time series data to LLM to make predictions. You can use that model. So that's the idea, but this needs an orchestrator. So this box actually is the orchestrator. This LLM does the orchestration and decides when to get help from outside world. So this, by the way, this is actually being, we are actively trying to standardize this. We've had joint workshops with International Standardization Organization, with IEEE, even with HL7. Some of those workshops are recorded and are available on our website. We had a hackathon last year with NVIDIA in the Bay Area in November. And also we're going to have another hackathon in November this year, 2025, in the IEEE BSN, Body Sensor Network Conference at UCLA. So if your students are interested, or if you are, please feel free to join our hackathon. We will announce it soon. And yeah, let me show you one quick demo. I have 2 demos and then I'm done. And let's watch it together. Or maybe I can do another thing. I can just open the website, because this is a website, opencha.com. As I said, the GitHub, everything, all the code is there. And we have a lot of also videos about our workshops, our tutorials. And the demo I want to play, that I just wanted to do it from here so that you can also find it in the future, is about the use of an LLM for food recommendations. But this is just a demonstration. You can do anything you want. It's really application agnostic. Please let me know if you cannot hear the audio.
In this video, we demonstrate an example of personalized food recommendations on OpenSea Che.
I cannot hear the audio.
We first select.
Here.
You guys can hear it?
Yeah.
Please give me a moment, because I cannot hear it. That's surprising. Let me change my speaker settings. Maybe it's my speaker is the.
The tasks.
Okay. Can you hear me still?
Yeah, you're good.
Perfect.
In this video, we demonstrate an example of personalized food recommendations on OpenSea Che. We first select the tasks that OpenSea Che can perform to generate the response. We select the task to interact with users' food data and health outcomes collected from external wearable devices, and one task utilizing causal inference algorithms to estimate nutrition effects. Then we take 2 tasks retrieving food nutrition content relevant to the user's query and requesting additional information from the user. Let's start by asking the agent to show my personal nutrition effects on a specific health outcome.
This chat now on this demo has access to this person's data, 2 years of data. This person collected his data or her data. I don't know the gender. The data for more than 2 years. Every day, Oura Ring was used. We have sleep, we have heart rate variability, we have heart rate. This person logged the food every day, all the breakfast, all the meals every day. Even used blood pressure monitor every day, scale every day. So we have a very deep end of fun data of this person. Now this person is asking, could you show me, and these keywords are important, right? Could you show me my personal nutrition effect on deep sleep? So this person wants to get recommendation down the road on the how to improve deep sleep.
Such as deep sleep. To do this, OpenSea Che will collect data from a food log and deep sleep information tracked by a wearable device, subsequently estimating the causal effects of nutrition on deep sleep. The response will reveal the nutrition effects on deep sleep, with values indicating the estimated average treatment effects of the nutrients per unit. We can also ask for food recommendations by querying the foods to improve certain health outcomes. For example, we say could you recommend me a food to improve my deep sleep duration?
So what happened so far, all this data is personal effects. For example, the model detected that the external model, that this person, whenever this person had food rich in vitamin E, or for example zinc and so on, low in caffeine, had a better deep sleep. So this was done by an external model. But now the LLM has that information, and now this person is asking, okay, what type of food should I eat? And for this part, the LLM uses this internal knowledge to go and find foods that are rich in this or low in certain things. So the second part is actually the contribution of the LLM, not an external model.
This will trigger the agent to execute the retrieve food task to obtain the relevant foods and their nutrition contents and personal nutrition effects. The response demonstrates the food suggestions to improve the deep sleep and the explanation based on the estimated personal nutrition effects. The recommendations are explainable. By querying with "Please explain your recommendations," OpenCHA will display the rationale behind the food choices, focusing on their nutritional impact. But what if you're missing an ingredient or food? No worries. OpenCHA's interactivity comes into play. Remember that this isn't just a static food list. It's a conversation with your dietary needs. Ask a follow-up question like, "I don't have the recommended foods. What are my alternatives?" And OpenCHA adapts, offering alternative suggestions. By calling the tasks, OpenCHA not only delivers nutrition-oriented food recommendations but also enhances the user experience with personalization, explainability, and interactivity. This ensures a more user-friendly.
Yeah, so this is actually one demo. We have other demos. One, in fact, is on stress detection using the data coming from wearables. So I encourage you guys to watch some of those. I also have my last demo, 4 minutes, and then I'm done. I talked about all of those just-in-time interventions and technology we built at our center. So that technology actually is now also available to a broader community. So if at your center you want to also use that technology to run your studies, please reach out to me. And the platform is not called this for building living lab, it's called CenterLive. Let me also play a quick demo of this platform here.
Let me show you how CenterLive makes setting up a study with wearable devices and mobile apps quick and easy. What usually takes months can now be done in just a few steps. CenterLive has two main parts: a participant-facing mobile app, available for download on Google Play and the Apple App Store, and a researcher dashboard. Together, they make designing and running studies with sensor data super simple. Here's how CenterLive can be used in a real-world study. Imagine you're investigating how physical activity affects sleep, stress, and depression in pregnant mothers. You want to track sleep with a smart ring, monitor stress levels using a Garmin smartband, and assess depression with PHQ-2 EMA surveys. Let's see how you can set this up easily with CenterLive. Multi-device integration. Adding devices is a breeze. Just pick what you need, and with a few clicks, they're integrated into your study. You can add multiple devices into a single study. CenterLive partners with leading device providers to deliver high-resolution research data directly to its secure platform.
And actually, that's the idea. For example, we, through our partnership with Garmin, we get raw accelerometers data for actigraphy, or we get interbit interval for every heartbeat that you can do comprehensive HRV analysis. So because we have access to their SDK. So the idea is really kind of getting more research grade data out of these devices. And if you wonder why we built this platform, because we noticed that for each project, we are reinventing the wheel by having another custom app, another device integration, and so on. After a few studies, we noticed that there are a lot of common things. So we made it a service so that now at least those repetitive parts doesn't need to be re-implemented, and it can be just quickly added.
For participants, devices appear ready to connect in the app, with privacy fully protected at every step. All data on CenterLive is de-identified, and participants join studies using a one-time code. No sign-up, email address, or personal information required. Real-time questionnaire design. CenterLive's questionnaire design tool makes it easy to create surveys with various question types, like multiple choice, text input, and more. As you set up your questions, for example, for the weekly PHQ-2 survey, CenterLive lets you instantly preview how the app will look on the participant's mobile device. This tool also gives you the flexibility to schedule surveys exactly how you need. For example, setting specific days or times to reach participants when it's most relevant.
And everything is through push notifications because the data is the identity. We don't have any other information from them. And also automatic reminders can be set if they forget to fill out EMAs or forget to wear a device, they'll receive automatic reminders.
In our case, pregnant moms will receive the PHQ-2 survey every week. Just-in-time intervention. CentralLive lets you easily design and schedule just-in-time interventions. Simply create the content you want them to see, and CentralLive takes care of the rest. For our case, we're designing a physical activity intervention based on ACOG guidelines, which recommend 150 minutes of moderate exercise per week. Finally, we can schedule our designed intervention. In our case, we are sending interventions every day. CentralLive will send daily motivational messages that encourage safe activities, like walking or gentle yoga, helping participants stay active and work toward their 150-minute goal. CentralLive is a closed-loop platform, allowing you to both schedule interventions and trigger them automatically based on real-time events. For example, you can set the platform to deliver a sleep hygiene intervention, only on mornings following a night of poor sleep quality, based on measurements from devices.
And I would say this is maybe the only platform out there that can do something like this, because if you want to implement something like this, that you really read data from devices and integrate and trigger an intervention in a personalized way only based on those readings, it's months or maybe years of implementations to have a robust system to really be able to do that. And that's what we learned in that loneliness study. And we had to redesign the platform to really make it robust because that's critical. Here's just a simple rule-based kind of triggering. So you just say, okay, I want to only send it when oral sleep quality is low, or I want to send it when blood pressure is below or above a certain limit. But the idea is to even be able to embed your machine learning models like what we did in that loneliness there. We don't have it yet with the user interface, but that's something that manually we can integrate.
Safety alerts. CentralLive even watches out for participant safety. Set a heart rate range, say 60 to 140, and you'll get automatic alerts if there's ever a concern, so you know they're safe.
We needed this feature for pregnant mothers. That's why we implemented this.
You can see participants' alerts inside the dashboard. Adherence tracking. You can monitor participant engagement in real time, including PHQ-2 responses, device usage, and progress toward activity goals. This comprehensive tracking makes it easy to monitor your study and keep participants actively involved. By selecting a specific device, you can also view its wear time for any chosen date, giving you detailed insights into device adherence and usage patterns. Download the data. Finally, you can effortlessly download participant data through a secure link. Each download request provides key details, including the request date, relevant participant groups, the selected time frame, and the current status of your download.
And we have cleaned up also the data. So data usually coming from sensors are messy, like formats like JSON or XML. But here you get like clean CSV files with very clear headings that can be directly like uploaded to your R or SPSS and so on. And the platform, by the way, is also HIPAA compliant. Yes, I think that was the last part of my presentation. I have backup slides and so on, but if I think for the sake of time, I think perhaps I can stop here and take questions. Thank you so much.
Thank you. That was fantastic. We only have a few minutes left, but let's open it up for questions from the group.
Yeah, so I noticed that most of the studies had a combination of a smart ring and a smartwatch. I was just confused because they had the similar physiological sensors. Why did you not like complement smartwatch with something that had like different physiological sensors?
That's a great question. These studies were like we ran these in about a few years ago. At that time, Aura was Gen 3, if I'm not mistaken, and only would monitor certain data during night. If you remember recently, like Gen 4 or Gen 3 and 4, Aura was also monitoring, for example, HRV and HR and those things. So we used Aura mostly for sleep and nighttime kind of measurements. Whereas for the actual Samsung watch at that time, we tapped into the watch and to get like raw PPG signals. But many of our participants were not wearing it overnight, so it was more the redundancy to have, first of all, more access to raw signals, but also the technological limitations. But let's say if I want to run the same study these days, I don't even need either of them. Honestly, I have also even an R1 doing exactly that. I would just go with Garmin because now with their SDK, you have access to, almost raw signals and day and night. So that was like the technological limitations at that time. Right now, I don't really think we need both of them. You're right.
Other questions?
And by the way, another reason that I would not use Aura anymore for that purpose is A, it's more expensive these days. B, it's not giving me any more IBI. At that time, it was giving me IBI. And C, it charges every month a subscription fee that I hate, honestly. I rather pay once something and just use it.
So thank you. So this was really interesting. And so I apologize. I feel like I'm in my dystopian era. So that's it. I feel this tension when I think about all the research with monitoring and wearables, right? Because so that we collect more data on our cars than we do our kids. Like part of me is like, well, it's kind of because I don't care what someone does with the data about my car, but I do care, right, about the implications of with kids. And so I'm thinking about sort of I think a lot about as a researcher, like how do once I do something and the results are out there, I don't have control over how it's used. And so I'm curious about how, as we collect more data as researchers and discover more about the connections between human behavior and outcomes, how we think about our responsibility to not let that be used in ways we wouldn't want it to, right? So just for example, I'm thinking about like a study of pregnant moms. There's been movement in some cases around, charging women, right, who have injected drugs during their pregnancies and harmed their kids, bringing criminal charges. Like,
Yeah.
where is it? What happens if that line gets pushed down? It's like, well, you're not exercising enough, and I don't know. And so as I think about that with everyone, or even like with kids in education systems, if we find links between certain things and learning outcomes, do we make distinctions early on about who's deserving of certain interventions and who's not? And I'm curious about how it's just something I think about as I think about engaging in this work more and more.
Well, I would say all of those concerns are 100% valid, and some of them are also stuff that keep me awake at night and thinking about it. Uh, I think these days, that's why we are also we have started having a new unit in our center, more actively discussing the ethical aspects of all and considerations. I'm not the best person to answer these things because I'm more like the tech enabler in all of these proposals on projects. I'm just one of the PIs or QIs. I closely collaborated with domain experts. But from my side, I always at least try to do my best to make sure privacy is preserved. We kind of don't reveal certain sensitive data. We even don't use it in our models because I do also extensive research in privacy from sensors. So that part, that's what I do research, but I'm not really a good person and qualified person to answer your very valid question on those aspects. And I love to also be part of activities on that, yeah, and learn more. I'm sorry that I'm not giving the.
No, it's okay, and I'm sorry to be like, so, like.
No, you're
Yes.
right. I don't
All of
agree.
the possibilities of it, and then I also, particularly because I do work on youth, and so I do think about like, where are the lines when you work with youth about what, like, not even this individual study, but down the road, how things get used, I just think a lot about it.
Absolutely. Yeah.
I see. Oh,
I did have another question. So, I noticed that a lot of analysis does not happen on the edge, I mean on the device, but it is happening on the app that is the apps that are being created, right? And the apps sort of like act as both the analysis and the interface for the data that is collected from the device itself. I was wondering, I mean, what are the blockers that people in the variables industry face for all of the analysis to happen on the device itself and alert you in real time? So, for example, a couple of years ago, I was working on anxiety detection, right? And I was pulling data from a smartwatch. But then ideally, I would have liked for it to happen on the smartwatch itself instead of a third-party app to do the job. I mean, what are the blockers that uh, the variables industry faces in a situation like this?
Yeah, to me, the trade-off, because I used to also do a lot of research in sensor design in my previous life, like power efficiency of devices, like connectivity and those things. Uh, in studies that we ran, in fact, most of time the models were in the cloud, not on the app. So we had to stream all the data to go out to our backend. We had, for example, here the loneliness model in the backend and would trigger so the mobile was more just an interface. But why we didn't do that on a mobile or on a device? Primarily, one reason was the computation power was not enough oftentimes. Or even if it was enough, it would drain the battery super quickly. So we had to just stream it to the backend to be able to run some kind of more, especially when you have personal models. So to me, like still some systems considerations of wearable devices and how to say making sure the feasibility, because you don't already mobile phones battery like last less than a day. If you keep many of these sensors on, and also you want to do continuous inference in a few hours, they will run out of battery. So in my opinion, still like many of these hardware considerations are important. That's why we did more or less everything in the backend. So all the data was sent to the backend, and we almost for tracking we use a smartphone, for example, for data collection, but not for the computations or modeling. We just even our app in both Central Life and here is actually a web app, if you will. It's an app, mobile app, but it's a service site, so it needs internet all the time to work. Without internet, there is nothing there. So it's not like a local app that you install on the phone, yeah, and can work independently without internet. Yeah, does it answer your question?
Yeah, thank you.
Yeah, you're
Well,
welcome.
thank you. I know there's probably many more questions. I have a little list I'll follow up to ask, but really, really appreciate you joining us and sharing that, that the systems are quite amazing that the team has developed. And it's really exciting to see the applications and amazing work that you're doing. And we really appreciate you coming and sharing it with us. So thank you so much.
Thank you so much for having me. Thank you. Feel free to reach out to me if you guys have questions or one-on-one discussions. I would be happy to chat.
Sounds great. Take care.
Thanks.
Thank you. Goodbye.